Hi, I'm Alyssa.
I'm Grace.
And I'm Sienna.
And we have characteristics of the trig function, including sine, cosine, and tangent.
So, for our trig characteristics, the first thing we're going to go over are some important definitions that you need to know for this unit. So for the first definition, we have domain, which is a set of all possible inputs for a function, which is also the set of all the x values. So in this case, if they had arrows on both ends of the graph, then it would be the domain, so it would be negative infinity to positive infinity. And the next is the range, which is similar to the domain, it's just with y values. It's the set of all possible outputs for a function. So in this case, it would be from -1 to +1, because that's where the y values start and end. And then next we have the extrema, which is the point where the graph of the function changes behavior, also known as like the highest and lowest points. So here is your extrema, here's another one. Our next definition is x-intercepts, and they're all points where a function crosses the x-axis. In this case, it's the red dots that go along the x-axis here. So we have 0, 0, pi, 0, and then 2 pi, 0. Another helpful hint is that it's always when the y coordinate equals 0, so like in this case, all the y coordinates equal 0. Okay, the next definition we have are asymptotes, and they're it's the imaginary line that a graph approaches but never touches. So like in this case, this is the asymptotes here, and like it approaches the dotted line but never fully touches it. It's also points in the graph where the function is undefined, and so in this case, the asymptote along the dotted line would be pi over 2, and then 3 pi over 2. Next definition is the central axis, and it's the imaginary horizontal line that cuts through the center of the graph. So like obviously it's imaginary, but in this case, the central axis would be y equals 0, and it just differs depending on the function. Next we have amplitude, and it's the distance between the central axis and the extrema of the function. In this case, the amplitude is 1. If you think back to physics, it's kind of like the amplitude of the wave. It's also the you can think of the highest point from like the origin to the y value, or the measure of the origin to the lowest y value. Next we have period, which is the time it takes to complete one cycle of the pattern of the function. So in this case, from like, once again, thinking back to physics, you go from the crest to the crest, that would be one period, or if you went from like the trough to the trough, that would be another period. So in this case, the period would be 2 pi. And then we have frequency, which is how many cycles of the pattern of the function repeat over the length of its period. So for this example, the frequency is 3, because if you go from here to here, it's 1 period, and then here to here is another period, and then here to here is your third period, so that means your frequency would be 3 for this example. So now we have a matching worksheet that's going to test your knowledge of all the definitions that we just went over.
Since we're going to be graphing our paired functions, we're going to make ourselves a t-chart. And our values are going to start off at -2 pi, -3 pi over 2, -pi over 2, 0, and then they're just going to reverse. So we're going to do pi over 2, pi, 3 pi over 2, and then 2 pi. And these are just values from the unit circle, which we already learned, so hopefully you'll know those. And we're going to do 0. So that's just a sequence that's going to repeat with all of your sine graphs unless you have transformations. So then we're going to make ourselves a little sketch. Okay, so that's what your graph is going to look like. And so for all of your sine graphs, they're going to look like this kind of wave pattern. So now we're going to move on to our characteristics. So for this graph, your domain is going to be all real numbers, so -infinity to positive infinity because you have arrows extending both ways on the x-axis. We're going to have our range. And your range, your lowest y value is going to be -1. It's going to go all the way up to your highest value, which is +1 right here. So it's going to be including, so you're going to do it in the bracket like that. So it's -1 to all the way to +1. Our x-intercepts. We're going to have those at -pi, 0. Remember, these are just when the y value is 0. So we're going to have -pi 0, -2pi 0, and 0, 0, pi 0, and 2pi, 0. So next we're going to have our extrema, which we're going to have maximums, which remember are our highest points on the graph. So those are going to be here and here. So it's going to be -3pi over 2, 1, and pi over 2, 1. And then we're going to have the opposite with our minimum. So those are going to be our lowest points on the graph. And we're going to have -pi over 2, -1, and 3pi over 2, -1. Okay, so next we have the equation of our central axis. So this is always going to be y equals something. And for this one, you have to visualize like how is it cut in half. So it's cut in half across 0 right here. So y equals 0. And we have amplitude. Since the trig graphs all relate to the unit circle, all of the amplitudes for the sine and the cosine graphs are going to be 1. And tangent doesn't have amplitude, but we're going to get there eventually. So it's going to be 1. And we have our period. And remember, that's the point from here to here. So like from one cycle to the next, it's going to be 2pi. Now we're going to start with our cosine graph. And we're going to keep that the same. And so our x values are going to be the same for sine and cosine. And honestly, these graphs are very, very similar, but there are a few slight differences. So we're just going to go over those with y'all. So we're going to start with 1 instead of 0. 1, 0, 1, 0. Okay, so this is right. And once we start transforming these graphs later, these numbers are going to change a little bit. Okay, so this is what our graph is going to look like. It's very similar, except you'll notice that it's kind of just flipped, whereas this one started up and then started down and went up. This one starts up and goes down. And that's just because of our flipped y values. So once again, our domain is going to be all real numbers, because they have those arrows extending to infinity on both sides. And our range is also going to be the same, -1, 1, with those brackets to include the values. This is where it's going to get a little different. Our x values, our x-intercepts, sorry, are going to change. Max values are going to be at -2pi, sorry, not 0, 2pi, 1, 0, 1, and 2pi, 1. And then once again, our opposites are going to be -pi, 0, and pi, 0. Then our central axis is also going to be y equals 0. Our amplitude is once again going to be 1, period, same going to be 2 pi, and frequency is also going to be 1. So those graphs are very, very similar. So once you know one, you pretty much know the other one.
Okay, so let's start. So we're going to do tangent, and tangent is a little tricky. It's a little tricky from cosine and sine. It's a lot different. So first we're going to start with the x values and go from 2 pi and 2 pi. Okay, so that's a lot of numbers. So again, it's a little bit tricky, but once you know these first 8, you just have to repeat them in the same order. So if you couldn't tell, you start to get a pattern. -1, 0, 1, undefined. So now let's do our graph, which involves a lot more than sine and cosine. So start with your x values on here. If you do this right, you'll have 8 values on each side. So 1, 2, 3, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And all the areas that say undefined are going to have your asymptote, so that's going to be the dotted line. Okay, so this is our graph. Learn it, live it, love it. Okay, so let's move on to our domain. So their domain for tan is different. Go figure, oh my gosh. So let's go. Starts the same, negative infinity to positive infinity. Except, this is where we mix it up. Except where pi over 2 plus pi k, where I have to go under k e through z. Okay? So basically what this means is that it's all real numbers except in the part where it's interrupted by the asymptote. Range is also different. So the arrows are going both ways, up and down, so it's negative infinity to positive infinity. X-intercepts are where the value of y is 0, so 2 pi, 0, negative pi, 0, 0, 0, and then under. Just kidding. Ah! Okay, so then for our maximums, get this, we don't have any, okay? Because there's no, this isn't a wave, so there's no up or down. So there is no maximums and no minimums. Central axis, there is not a central axis, okay? So none. I wrote no, but I should write none. Amplitude, again, no amplitude, not applicable. And here it is pi, okay? And our frequency, that is is the same one. So good. So yeah, thank you for coming to my TED Talk. I'm glad that you want to learn more about about the characteristics of trigonometric functions.